In these questions, we're going to be looking at how to use an analemma. So here we've got our analemma, and sometimes in the exam they don't label the axes for you. So the top axis is the equation of time, and the side axis here is the declination. So use the analemma to determine the equation of time in February when the declination of the sun is minus 15 degrees. So we look at our axis for declination, we identify minus 15 degrees, and we go across. Now you'll notice that it hits the graph at 2 points over here and here. This one is in November and this point is in February. So looking back at the question, it asks us in February, so we're going to use the second point and then we'll draw a straight line with a ruler, better than mine, and you'll see that the equation of time at this point is just below minus 15, so approximately minus 14. Use the analemma to determine the declination of the sun in March when the equation of time is minus 5. So we're going to look at the equation of time axis, which is the top axis, and the equation of time at minus 5 will be here. And again, we can draw our line down. Now we'll see that it actually would hit the point at 1, 2, 3, and 4 different points. So we're going to choose the one at March, which is obviously here, and we're going to draw our line straight across to our axes. And you can see that that would be somewhere around plus 3 degrees. So the declination when the equation of time is minus 5 in March will be around about plus 3 degrees. Use the analemma to determine the equation of time on the date of the autumnal equinox. So this is a bit more tricky, but on the autumnal equinox we know that the declination will be 0. So again we can draw our line across. Now we can see it hits the graph at 2 points here and here. So we want to identify which would be the autumnal equinox. Obviously here in September would be our autumnal equinox, and over here would be our spring equinox. So drawing our line vertically up until we hit the graph at the top, we can see that the equation of time would be approximately plus 7. Use the analemma to determine the equation of time on the date of the winter solstice. Now we know the winter solstice will be December the 21st. It's also going to be the point where the sun is the lowest in the sky. So it'll be the point at the lowest point of the graph over here. So we want to determine the equation of time at this point. So therefore we would go all the way, drawing our line straight up, and you can see that it would hit perfectly at 0. So the equation of time on the date of the winter solstice is 0. What is the declination of the sun when a sundial is fast by 8 minutes in November? So if it's fast by 8 minutes, then we're going to find that on our equation of time axes. So 8 minutes would be approximately here, somewhere between plus 5 and 10. So we'll draw our line all the way down until it hits this point here. This point is November. Obviously this point would be in September. So going across, we can see that it's hitting approximately around about minus 22 degrees. So the declination of the sun when a sundial is fast by 8 minutes in November would be minus 22 degrees. And finally, what is the equation of time when the right ascension of the sun is 12 hours and minutes? Again, this is a tricky one. So we need to think about when does right ascension begin. So right ascension of 0 hours would be the point where the spring equinox is taking place, where the sun is moving from the southern hemisphere into the northern hemisphere and is directly over the equator. There would be 24 hours of right ascension, so 12 hours would be exactly halfway round. So exactly halfway round would be the autumnal equinox. So when the equation of time, when the right ascension of the sun is 12 hours 0 minutes, would be the autumnal equinox, and we know the autumnal equinox will be when the sun is at 0 declination. And so it'll be this point here. So going up to our graph, again, we can see that the equation of time will be plus 7.